All right, this is direction of the force on a wire, right? We predict that there's a magnetic force on a wire. This is, I've basically made this little square thing, and I think it's like 30 windings. So when I put 5 amps through one of these, we really have 150 amps, and it's going this way. So I've got the wires, by the way, labeled up here. I don't know if you can see this. But up here, I've got them labeled plus and minus, and you need to hook the power supply up like that. Okay, and then I've got it hooked to a DC power supply. I turn it up until there's about 5 amps. It seems to handle 5 amps and just sort of get warm, right? And then there's two notions here, right? This is the north pole of a big magnet, that's the south pole. So the magnetic field is defined as from north to south. So the magnetic field is upward here, from the bottom to the top. The current is that way, right? Okay, so we do the right-hand rule, whichever way you do it, right? Index finger is the current, magnetic field is up. We predict that the force will be outward, right? Drum roll, please. And of course, it pushes it out, right? So that's kind of fun, right? I think that's all there is. Oh, and then you can take this guy away. And you can take the magna probe, okay? You can take the magna probe and you can put this guy in there, right? And that's this thing basically, the red end of that points, that's the North Pole. The red end points in the direction of the magnetic field, right? So this rule is thumb in the direction of the current, fingers wrap around in the direction of the magnetic field. Right, so you can see that it circles it. This is a little bigger. It actually works. It's on a little pivot there. Right, so that's the direction of the magnetic field. It wraps around the wire, right? And then you can also look at this whole solenoid in a bigger sense, right? Okay, so now we're talking about this whole thing as a magnet itself, right? So which way is the North Pole? If we've got a loop of wire like this, the North Pole, we wrap our fingers in the direction of the current. Our thumb is the North Pole. So this thing here facing you is the North Pole, facing me is a South Pole. Now we can test this, right? If this is a South Pole facing me, I can take the South Pole of this magnet, right? Put it up against that, and it doesn't like it, right? The South Pole repels it, it turns it around so the North Pole is facing it, right? Okay. If the thing facing you is the North Pole, I can take this North Pole and point it to that thing, right? And then when I let up, let it spin, right? Okay. And really, you know, of course, what's going on here is that the magnetic field is a big toroid, right? It's looping around this thing. All magnetic field lines are loops, and so they're coming out of the front, going into the back, right? If it's a pole that has the field lines coming out of it, it's a North Pole, and if they're going into it, it's a South Pole, which leads to the inconvenient truth: the Earth's north geographic pole is a magnetic South Pole. It's gonna rock them.